Welcome back, data leaders and Python learners. Master art of Big Data ETL with Pyspark. ETL 175 million records using Kaggle environment. What problem we were facing? The challenge was that we wanted to use Spark program to in our local file system or in a file system which is not actually a data warehouse, and learn how to work with big data concepts. So we wanted to have big enough file, and we wanted to have compute power, and we wanted to avoid using warehouses as much as possible and understand the overview. We got a picture of all these things in the last video. I will also tag that video in this along with this video. Take a look at that. But in this video, what we are going to do is, our objective is a little more different. So we are going to practice on massive data sets on Kaggle. Okay, and we are going to choose Uber New York dataset. You will be seeing that in a moment. And we have to load the dataset into Spark session, do some transformation. Okay, so here you see that, right? So we are actually starting the ETL process. And after that, we need to explore the transformation, more transformations, using group by, using with column, using select clauses. It doesn't stop there. After using all these things, we are going to bring in the Spark catalog and use Spark SQL on Spark catalog tables. And finally, we are also going to work with partitioned data and understand how to recover partitioned data. So this particular video is going to give you a different view on the big data environment using Pyspark and Kaggle environment. And the notebook is a Kaggle notebook. You can go to this link and you can get this notebook. It is available on the Kaggle as it is already shared in Kaggle, so you can go there. After this video, I'll be concentrating on big data build tool or DBT tool. It is again a Python library, and it is also used for a different kind of an ETL. So we will discuss that in the next video. If you like the content, do like it. If you have any comments, do leave the comment in the comment section, and subscribe to this channel so that you can get the video updates as soon as possible. Once I update, now we are going to go to the Kaggle environment. Okay, let me shift to the Kaggle environment, and you see that I have already opened this Pyspark Uber NY ETL notebook here, and I have started editing it. If in case you don't want to use Kaggle environment and you want to get this notebook, then you can go to this particular GitHub repo and you can get this particular file, Uber NY ETL to Spark catalog. This file is what you should download, or you can download the entire GitHub repo by cloning it. It's your call. Now what we are going to do is, we are going to work on some interesting data. The data that we are going to work on is the Uber NYC for hire vehicle strip data. Okay. I also explored Airbnb ratings dataset and AWS honeypot attack data, but they were actually smaller than what we are going to see. So in case of Airbnb data, Airbnb reviews.csv is 3.22 GB. That could have been an interesting activity, also interesting data set. And when it comes to Uber NYC vehicles data, we have it in Parquet file format, and the number of rows in this Parquet file is 174.5 million rows, actually records. So rows are called as records, and there are additional information here. Since this particular way of working with Parquet files is actually interesting, rather than just CSV files, I wanted to take this data set and show it to you guys. So that is the main reason why I chose Uber NYC for hire vehicle strip data. Okay, and you can get it in the in the Kaggle environment itself. Just click on add data, and if you search for Uber NYC data, you will get it. Okay, so it's not a very big challenge. You can get the data without any trouble. You don't need to even download the data. So that is the advantage, right? If you are going to use it in Kaggle environment, you don't need to download the data. Okay, And if you're going to use this in a different environment, like if you're going to download this particular file, it will actually get downloaded to your own server, okay, your own work environment, then all this path will have to be changed to your local environment. This is all based on Kaggle environment. So ensure that once you download it, you have to appropriately change the path and download the data also. To download the data from Kaggle, I'll be having a separate video on how to work with Kaggle API. I'll be discussing that also. But just to give a brief, you can come here and click on this particular link and click on open new tab. It will open the data set, the Uber NYC for hire data set itself. It will open and it will give you all the information regarding the data set. And on the top you can click on, or here if you click, you can say copy API command, and once you copy the API command, you can use Kaggle API and you can download this data set. So it is as simple as that. So that's not a very big challenge. And let us start the activity now. First and foremost, you'll see that we are going to have a series of challenges, and you'll see how to solve it. First and foremost, we need to import the data into Kaggle environment. And as I already shown you that this data set is almost 5 GB, okay? And this data set is in Parquet format, okay? It is in Parquet format and it is one of the best compression format, okay? So actual data will be much more bigger. First, we are going to load the data into Kaggle environment. We are going to start the Spark session, read in the data, do some basic analysis, initiate transformation. So here we are extracting, we are doing the transformation, then we are writing the data to Parquet file, and the final aim is to write it to a Postgres instance in RDS. But this will be covered in a different video altogether. But this is the final activity. Now what we are going to do is we are going to start the Spark. We are going to import the necessary libraries and the functions. So I'll be using these functions from Pyspark, and you must install using pip install Pyspark. Ensure that your environment is having Pyspark, and then you start by looking at the data set available. So in this notebook, all the 3 data sets are available at Kaggle input, okay? The same thing you can actually use using OS module, the OS module of Python. You can use that and you can actually list the directories also. So you will get it as list. So you see this list. Now what we are going to do is we are going to start the Spark session, okay? And once you start the Spark session, you have to read only the first part, okay? Ensure that you are going to read only the first part. If you are going to explore this notebook on your own, and if your system's RAM is 4 GB or 8 GB, then ensure that you are only reading the first file of this Parquet. Okay, let me tell you why. So let us read the first file of this Parquet. I am going to execute this particular cell, and using the shortcut key Control Enter, and it has already read the file. So now I am going to use uber raw Parquet show. This is one of the methods of the Pyspark data frame. I'm going to execute this, and you will see that it shows all the columns, and for 2 rows it shows. It will show me the 2 rows. It will show 1 row and 2 row, and it will show me the column names, all the column names. Okay, and now I am going to count. Now you will be surprised. So this particular one file, this one file is containing almost 11 million, almost 12 million records. Okay, this is containing 12 million records. Yeah, and what will happen is, okay, let me tell you what will happen. So now what I'm going to do is I am going to move. Okay, let me go here. I will show you. So all this file is there here from 2021 January to 2021 December. All this file I'm going to move into this working directory. From there only I can work easily. Okay, I cannot directly work from here because it is difficult. It is having other files also. I don't want that file. So what I'm going to do is I'm going to create a directory. Okay, so this directory will get created in let me show you. It will get created inside the Kaggle Kaggle. Yeah, it got created here. You saw that, right? This got created after I executed this environment, this particular execution. Now I'm going to do is, I'm going to, with this cell, I'm going to copy all the Parquet files from this folder, that is from this folder, to Uber NYC for hire folder. Okay, I'm going to execute this, and it will take some time. Okay, I think it is almost 5 GB, right? So it is moving from one folder to another folder. So you need to give it a little bit of time. And as I explained to you, Kaggle is a container, so it will take little time to copy it. So it has done the copying right now. Let us go and check it right here. I'm going to execute it, and you will see that all the files have got copied. So all these files are copied into this area. So clicking it in the UI might take little time to populate. So I will not be using UI. I will be using only the command line as much as possible, or the cells as much as possible. And now what I'm going to do is, this is going to be a tricky process, okay? And this will actually crash the notebook. So I will show you what happens. So when I read the file, it will read it. So there will not be any issue, okay? And I'm going to count it now. And once I count it, you will see that it has got these many values. So 174, 596, 658. So that is 174,596,652 records it has got. Okay. And you can do the print schema on the entire record. And now is the actual challenge. Okay. So now I'm going to work on one of the group by option. So I'm going to take this particular HVHSF license number and I'm going to group by. Okay. So it will not be an issue. So it will work. See, all this group by, everything will happen. So this is all happening from the memory. Okay. That is the benefit. So you come here and if you see, I'm using almost 390% of CPU and I'm using 10 GB of RAM here. So max I have 30 GB of RAM. Okay. Now I come down here and you see that I'm getting all the information. So this is almost 126 million is in this, and 47 million is in 005, and 04 has 8 million approximately. Okay. So what is wrong? So I'm able to read the entire file, 174 million files into the 174 million record into the Kaggle environment, which is having a CPU, which is having a Docker oriented CPU and a RAM of almost 11 to 12 GB. Okay, it can go up to max 30 GB, but 11 to 12 GB is a maximum, the regular maximum. Okay, and now you saw that, and now what I'm going to do is I am going to actually create the Spark SQL kind of a table inside the Spark environment. For that, I need to work with Spark catalog. In the last video, I explained how the Spark catalog works. Okay, so whatever data frame I am having, this data frame is inside the memory. So it is inside this RAM. Okay, now it is inside this RAM. You see this 10 GB. This 10 GB contains this data. This Uber full data is inside this 10 GB of RAM. Okay, and that is good. It is very fast. You can do a lot of things with that. However, it is always better to have the file written on your local database also. So for that, we are going to create a database and I'm going to execute it. And next you see that I list the database. You see that I have Uber NYC database here. And I'm going to list the tables. You will see that there's no tables. And now what I'm going to do is I am actually trying to filter. So initially I want to filter the data, filter Uber full data, and only select those data that is having the HV0004 license number. Okay, and I'm going to count it. It will say 8.9 million as we saw at the top. Okay, it is giving the same value. And now I am going to do some more activity. Okay, why I am doing all these things is that first and foremost, I need to initiate the transformation. Okay, I have already started the transformation. So I have already filtered the data. You saw that I filtered the data. I took only the HV0004 license number right now. So I am losing these two. So HV0003 and HV0005, both I am not touching because these are all massive files, massive data sets. And if I'm going to work with that level of massive data set in Kaggle environment, you know what is going to happen. It is immediately going to crash. However, assume that you are given such a mission. How will you manage this data? Okay, that is the real challenge, right? In data engineering, you are not always going to get everything that is at the top class. If it is there like that always, then everybody will be, easily doing it, right? Let us now think. So now I'm going to only work with HP004 dataset, and then I'm going to try to manage it with the memory that I have to ensure that my Kaggle environment does not crash. Okay, that is the major objective in this, which I did not actually tell you guys, but now I'm telling you. Next, what I'm going to do is I am going to use this function. This function is called as date format function. And this date format function is special inside the Spark SQL and Spark environment. Date format is not there in regular SQL. Okay, remember this. This date format has been written inside the Spark SQL only. Okay, let me also give you one heads up. Actually, we can actually go to sparkapache.org, and in sparkapache.org you can get all the information regarding the details that I'm discussing. So SQL and data frames, click on this. There is actually 4 modules in Spark. So one is SQL and data frames, another is Spark streaming, ML machine learning library, and graphics. Graphics is mainly in Java only right now. It's not fully into Python, but these 3 are into Python already. It's rewritten into Python. So click on SQL and data frames. It will go to SQL and data frames, and you will see that all the necessary data is shown to you. So you will get the overview of entire process. Okay, and you can also download Spark SQL and you can install it in your own location. But what we are going to do is read the Spark SQL and data frame guide. Click on that, and that will lead you to this guide. This guide will provide all the necessary reference. Okay, and whenever you get stuck somewhere, if you want, always remember that whenever you are working on a particular data set or a challenge, you need to first of all break down the challenge. What is the challenge I am facing? I am facing a very huge data set right now, 174 million data records, 174 million records. How will I start working with that? I have to divide this data. So how to divide the data? To filter the data. First and foremost, I will filter the data. So I filtered it based on the HVFHS underscore license underscore num. I use this strategy to filter the data. Okay, and I got a smaller data set, which is 8.9 million rows. Okay, and this will also contain the various months in this. Okay, this will not only be January or February. Okay, this will contain various months. So we will see that. Next, what I'm going to do is I'm going to further filter it. In order to further filter it, my strategy is I am going to use the pickup date and pickup date time column, and from the pickup date time column I am going to segregate the date. I'm going to create the date properly, and I'm going to segregate the day and month. Based on this, again I will go and filter it. So I will show it to you. So now I am going to use date format. Let me first of all go to the date format. Let us go to the SQL reference, click on SQL reference, and you will see that date time pattern. Date time is one of the major topic in SQL and also in Spark SQL also. So you can actually click on, before that, let us click on the functions. So if you click on functions, you will see there are lots of functions here, different functions. So click on date and timestamp functions, and you will see there are lots of date and timestamp functions. And in this, there is date underscore format. So this is the function that we are using, and there are other functions also. You can come down here and you can easily learn about that. No one is gonna ask you. And also in addition, you will actually get all the necessary examples also at the bottom. So whatever you want to learn, you can just use these examples directly. You can even copy it. So for an example, let us say I copy this. Just a minute, maybe this may not work. Let me try. Let me copy this. go back to my environment and let us use Spark SQL. Okay, I am using SPSQL. You see this? That is because I have already assigned spark.sql to SPSQL and spark.catalog to SPCTG. Okay. And now inside this, I am going to paste this. Okay, not this way. So I should always use triple quotes. Okay. Mistake. I'm going to paste this. Why it is all coming wrong today? Just a minute. Now let us see what happens. Okay, so here we see that I am not getting any output data. So it is telling that it is date truncated, and it is giving me the it is not actually executing anything, right? So it is not executing. So what is wrong? So let us go back and let us understand. So it should actually give me this value, but it is not giving that value. Okay. So what is wrong in this execution? Why this is not working? So the major point that you need to understand is that you need to actually use show here. Okay. And once you execute that, then it will show you the data. So you should have show here. Okay. The show method is what is going to convert. This method will convert the Spark data frame into the format that can be printed. Keep this in mind. Okay. So sometimes you will actually copy it from there and you come and paste it. You use the exact commands, but output will not come. That time, remember that you have to use show. We will be using show a lot in this notebook. Now that is how you do the understanding. You learn about the functions. Okay, so you can actually check out the other functions also. That is available here. Sorry. Let us go back to the notebook now, and I'm going to use the date format notebook, and I'm going to use pickup date time. So before doing that, let me actually show you how the date and time looks. Okay, here is the date and time. You see, it is actually a timestamp. So it is 2021 January 1st. By 12 o'clock 28 minutes 09. This request date time was a timestamp had come, and the pickup date time is again it was picked up on on the same day by 12:33. So 0033 is 12:33 night 44 seconds. So this is how the timestamp is. And now what we are going to do is we are going to take only the date, and then we are going to take only the day, only the month, and only the date. This is what we are going to do, and for that we are going to use date format option. So here we are going to get the date only. We are going to get only the date. If I give this format, I will get only the date here, and then I am going to do the same thing for request date time, and I am giving alias for everything. Okay, so this is how the format is. So I give date format, inside select I use date format, and I give alias. So all the columns I give alias, and for selecting the columns, just to select the columns like talls, trip time, tips, base, I need to use this function called as call. This you need to provide, then only it will work. And you can see the various columns here. So talls, base passenger, fare, tips, airport fee, all the data, all the column names are given here. You can find it out from the print schema. Now I am going to execute this. Okay, and you will see that it will be executing and giving me the pickup date, request date, and you see the dates, the day, the month, the tall, all these things will come out. So all the things that I asked here has been printed out here neatly. Now next what I am going to do is I am going to, here I showed, okay, always when I am building the actual transformation. So this is the full data. Okay, I am building the transformation, and first I am seeing it. Okay, take the full data, build the transformation and see it first, and then take the full data, do the transformation and assign to a new data frame. So this is what next we are going to do. So I'm going to assign it to a new data frame, and I assigned it. Here in this case, there will be all the months, not just January. It will have all the months. Okay. Next, what I'm going to do is I'm going to do further 2 more filtering. Okay. I'm going to further filter based on Jan month. I'm going to take Jan month only. Pickup month. So you see that pickup month. I'm going to only take Jan data, and the originating base number, this one, originating, yeah, this one, I'm going to use 02682. That is what I'm going to take. Rest of the all, I'm right now going to park it. I'm not going to use it. This way of working, I'm going to only show you the one step of this. But actually, when you do the programming, right, what will happen is, let us, it is like eating a full plate of food. Okay, so you have 174 million records. Yeah, you will have very big, if you have a very big server with you, then you can actually, take all the 174 million and work on it. But if you're not having, then what are you going to do? So you're going to split the data. That is what we are doing right now. Now you think about it. I can actually, once I'm filtering it like this, I can actually iterate over the month, right? And I can also iterate over the base number. And when I iterate over the month, iterate over the base number, and I iterate over the, where is that? The license number, I can actually get all the data and process it if I want to. I'm not anyway going to do it here. Okay, it will be more complicated for you guys to understand, but that is the actual funda. So nothing, everything in computer science is actually a problem and a solution. So once you understand the problem, right, the solution is very easy to come by. But if you don't understand the problem, then you will actually go for the wrong solution. Okay, so my intention is to show you that there is a way. Everything is a puzzle, so you can solve it by whatever resource you have got. Now I am going to filter it further, and I am filtering it, and it will again show the data. So this will only contain the Jan, and it will contain only the originating base data. And how to check it? So I'm going to filter it, and I'm going to assign it. I will assign it to this particular data frame. How to check what is the count? You will see that you will see that the entire count is only less than 40,000. So that much reduction we have done. But now you know that 175 million row data can be managed. See, we are not only processing it, we are managing it and then processing. That is the fun point of data engineering. So when the world gives you lemons, then make lemon juice, right? So that's how it works. And you see here, so it has become 320k lines. So from 175 million, now we are only concentrating on a very small area of the very big data. You can use this and you can start processing, and you can do a batch process of all this data step by step, and you can complete it using a very limited resource also without using data warehouse. So I'm not saying that you should not use data warehouse. I'm telling that there's an option. Okay. And now I am going to actually, do a group by on this. I'm going to group by using PU date, and it will show the count of based on the date on each day of January, how many transactions were happening. So it will show that. It will show the number of trips. So this is the purpose of group by on PU underscore date. This PU underscore date is the this column. Okay, and that where it is. So it will take a little time. Okay, and you'll see that the RAM is still 10 GB. It is not taking more than that, and the CPU is taking a lot of effort. So it's actually crossing its limit. And when you're working in Kaggle environment, give time. Sometimes what will happen is when you are experimenting, okay, when you take this data and you do something with the data, most of the time the Kaggle kernel will crash. It will say that Py4j is not available. It will say that the system has crashed and Py4j is not found. So such a error comes, it means that the memory has been used up completely. So the system has crashed. Assume that if you are going to do this on your own machine, your own laptop or your own server, what will happen is your OS itself will crash. Your OS will not respond, and you have to restart that OS at that time. So you have to restart your machine. The benefit of Kaggle is that all you need to do is, if such a thing happens, come here, and click on stop session, or you can say restart and clear all outputs. So any of this you can click and the session will restart. So, but you lose all the data, all the processing data, not the data. The data will be still there. So none of the data will get lost, or the code will not get lost. Okay, only the variables and the memory of the variables will be replaced. So you see the count here. Okay, I've got the count, but this count is off. So you see the date is totally different, and I'm not seeing any kind of order in this. In order to get some order and make a better transformation, first of all, we can write this data as a table. As I already told you, this is the place where we are going to use a Spark catalog. Okay, so we have already created the database Uber NYC database, right? Now I am going to save this particular filtered data Uber Jan B02682 under the where it is, yeah, here, under the table name Jan underscore B02682, and I am going to execute, and it will write. So this will basically write this particular table to Jan B02682, and always use mode ignore. Okay, in Kaggle this is required, or else what will happen is if you are going to restart the session, sometimes this will come and stop in this area and it will say that the table is already existing. Okay, so in order to avoid that, always use mode ignore. And then now we can start working on this table, right? We can use SQL, simple SQL. If you are, this is where the importance of SQL comes into picture. So now we can simply type the SQL. You don't need to use any of this group by filter, any of this date format. All these things you can type it inside these 3 quotes. So like these 3 quotes, you can type the entire query, and yeah, it is done. So it has saved the table. And now if you execute this entire query will get executed, and you see how nicely it has come out. Okay, and it's showing only the top 10 rows because I'm showing only the top 10 rows here. Okay, I'm not using limit. Okay, this limit is taken care by this show. Just a minute, I'll be back. So now that looks way more neater than the usual option that we used with the data frame, right? Where is that? Go up. Where is it? Just a minute. Yeah, here it is. How is this to look at, and how is this to look at? It's way too neater. Now is where we are going to do some actual work. What we are doing is that we will use the write. So we will take this Jan B02682 data frame, and then we will write it as Parquet. So we have now done the transformation, right? Now we want to write this as a Parquet file, and we want to partition by the request date. So we want to partition it based on the request date. Okay, and I'm going to execute this. And once I execute this, what will happen is in this location, the files will get written. The Parquet files will get written. The same type of files that we started with. Where is that? This same type of file. But instead of actually having 20, you see this kind of error. It is saying that the gclocker too often allocating this much words. So basically what has happened is the system crashed. Okay, and now no longer I can use this Kaggle environment. I have to reset the environment. So I have to click this and I have to reset the environment. And once I reset this environment, and then I can actually use it again. So the point here is that yes, there are still challenges in this. This is not a foolproof method as you saw right now. So this is called as crashing the machine. So this particular data is no longer a small data. So it is a big data. Okay, and when it is big data, you cannot work on purely a small file, small processor or small RAM. So that is why it was crashing. And let me get back to you in a moment. So I have restarted the session now. The session has restarted, and I have it will execute all the code. So it will re-execute all the code. It's like restarting the machine. So it will re-execute all the code, all the cells here. It will execute one by one, and it will come to this place where I was about to write it to the Parquet file. Okay. Once it is coming, once it has come there, I will restart. I will unpause the video. So the execution has been completed now, and the Parquet files are written. So sometimes when the system crashes, when the Kaggle kernel crashes, you can restart it, then it will work. And now if you come and check here, you'll see that the files are written here. And these files have a weird, these folders, these are all folders actually. These folders have a weird name. So it is saying request date equal to 11/01/2021. So basically what has happened is each and every folder will contain the data of that particular of the rows that contains that particular date. So if you go into that folder, for an example 01/01/2021, you will see that it has a Parquet file, and this Parquet file, if you read it, so you can read it using the same spark spark.read. Okay, actually we will be reading this in quite some time, so so let me continue with the video. We will be reading this again, and we will see how this helps, how this partition will help. Okay, now if you actually tried to save this data, okay, save this HV004, that 8 million rows data, if you records data, if you try to save it to the table using this command, again the system will crash. So don't try that. It cannot recover. So this got recovered because this was less than 400k data record, but this is actually 8 million records, so this will not work. And forget about writing 175 million records in single go, so you have to split it out. Okay, and now what I'm going to do is I'm going to start another transformation now. So this transformation has been completed. So we actually did the extract, transformation, and load, right? So we extracted the data. Where is it? We extracted the data from this full data. We did the transformation. 1 minute. So we did the transformation. We filtered it. We did the transformation. We modified everything, and then we took only this data, and from there we again filtered it. So Jan and this base number, and after doing all this activity, we pushed the data into this particular table. Okay, and after we pushed that into the table, we played with it. We basically use SQL, and we had some transformation and try to understand the information here. So on 1st of January 2021, the total tip was $4,073. Trip time was this much. This is all is in seconds. Okay, and total fare was 19,000. Wait a minute, it was 19,000. Yeah, I am reading it wrong. It is $196,959. So it is in 196,000. So like that, we actually got the necessary information. You can use this data and you can actually send it to your BI tool, and you can start working, or you can use Power BI or any of the visualization tool, and you can create a visualization. So that is, we have done the actual activity now. So ETL is complete. Okay, this is only one part of the ETL. So there is another one part of the ETL that we are going to start now. Okay, this part of the ETL, we are going to work on again the full data. This time we are going to group by based on license number, dispatching base number, and originating base number. So let us start. Let me execute. And what this will do is it will again do the count, and it will show us the count. So how many are there? And after that, I am going to assign that to Uber consolidated count. Okay, and then I am going to select. So I will be selecting the trip time, trip miles, driver pay, etc. from this data. Okay, and I am going to show the data now. Uber select data. So this is one of the simple way of doing the transformation. So I have not done anything out of this world here. I have just used count, and I have selected the information from the Uber full data. Okay, so that is what has happened. Now what I do is in the Uber select data. So in the Uber selected data, so here you see, right, this selected data contains only tolls, trip time, trip miles, driver pay, passenger fare. Rest of the columns I have removed from this from this data frame. Okay, I'm not using them. So this is another way of filtering another way of reducing the size of the data set. This is another strategy that we are going to, that I am following. I'm showing this right now using the show command. It will show the data set. And now I'm going to group by and I'm going to sum. So when I use group by and sum, what will happen is this sum will know which columns are numerical, like float and integer, and it will create, it will aggregate them by summing the values based on the HVF license. So based on this value, right, it will do the sum. And now if I show the license aggregate, this will show the various license aggregate, how it is, how much each of the license numbers are carrying the tolls, trip time, trip miles, driver pay, etc. So we will get that in this particular aggregation. And after that, what we will do is we will do the same group by on both dispatch base name. Yeah, you see this, right? So on HV004, HV005, I'm getting this. I'm only showing 2 here. Okay, if I remove this, okay, let me remove this. And if I execute this again, there is only three rows. So there should not be any problem in removing the 2 there. Why I'm using 2 is because if I don't, then it will show the 20 rows, minimum 20 rows of the data frame. So it will, in order to save my real estate in the screen, I have reduced the rows. Okay, so now it will show the 3 columns actually. So it is showing the 3 columns. There are only 3 license number, right? I am grouping by based on the license number. So there are 04, 05, and 03. So you see this here, and this is all having lots of decimal numbers, and this is not looking good at all. You cannot present it to anybody. How to make it more presentable? So first of all, let us actually do some more group by aggregations. So this time I will aggregate based on all the columns, and then I will again show it. But this time I will be using the truncate command, show 2. And in this case, we will count it. So it will have only 188 rows. So it will be very less. Because of this aggregation, all the data has been compressed and we are consolidated it. So you will see the consolidated information right now. This is another way of working. And after that, we will be writing that as a table. So let us see. It will take a little time because it is doing a lot of aggregation here. And yeah, you can check the RAM also. So it is 13 GB right now, and it is using 157%. And now it is counting the number of data in this. So here you see that, right? You see that the license fare, dispatching base number, and originating base number are all available. And the toll is getting, all the sum is getting calculated. And you can see the column name, sum, toll, sum, trip time, all this is coming at the top. And you will see that there are 188 columns. And I am writing this data frame into the table, save as table, and writing it over catalog. So when I use save as table, it will write into our Spark catalog. Okay, this should pass. So that should not be much of an issue. And you must be noting something, that whenever I'm assigning any value like this, so if I do some transformation here like sum and all, when I am assigning, it takes no time at all. It immediately gets assigned. Okay, once you execute it, there is nothing happening. So there is no this rose color bar here. But once I do like show or collect or some similar activities, then this bar happens. This bar occurs and you see that stage 48 or 43, and this stage increases and this arrow mark goes like this. Okay, this is called as lazy loading in Spark. What happens is Spark actually does not do the processing the moment you give it the command. It only does the processing when you are going to ask the result. So when you are going to show, when you are saying, okay, show me the result, then it will go back and check what and all has happened on this particular data frame. So there will be a directed acyclic graph. Okay, directed acyclic graph, DAG. So it will write the DAG inside, and it will use the DAG to do the calculation on all the data sets. So here you see that, right? You are actually working on a single node. Okay, but in reality, the Spark will be used on a distributed cluster, data warehouse. So whenever you are going to execute, write this command, and if you are going to try something out every time, it has to connect with all the data sets in different distributed nodes, it will be very costly and it will not be very efficient also. That is why Spark uses lazy loading. Okay, so that's just a trivia. So this table has been written, and we can now check the tables here. There will be two tables. So the okay, there is just a minute. Why there is only one table? There should be two tables, right? Why I'm getting only one tables? Just a minute. Display origin license. Oh, okay, no, I'm getting two tables. So I was reading it wrongly. So there are two tables here: display origin license and Jan B0268 to Jan underscore B02682. So this and disp underscore org underscore license. Both are under the database Uber NYC DB. Now we can start again using our simple SQL queries. So now you understood, right? Only when we write the data frame as save as table and give it a table name like this, after that only you can use Spark SQL. Before that you cannot use Spark SQL. It will not work. Okay, Spark SQL will not know that there is a table. Okay, Spark SQL will know that there is a table when that table is written in the Spark catalog. Where is that catalog? Just a minute, let me go up, and Spark catalog is basically the Spark metastore. So here, when you are going to create a database like this database will be created in the Spark catalog, and you can actually see in the catalog, I'm going to list the databases, and after that only the Spark SQL, the SQL module in Spark will know that, okay, there is a data table name called, there is a table name disp origin, disp underscore origin underscore disp underscore origin underscore license. So then only it will know. Okay, before that it will not know. So now it will work properly. So it should not be a problem. Now you can start executing the basic commands. Like here I'm saying select star from disp origin license, just from disp underscore origin license, and where I'm saying where is a way to filter. So I'm saying where dispatch base number is equal to B02875, and I'm going to execute it, and I'm going to limit it here. You see this, I'm using the limit here, not here. Okay, it will give me 10 rows. And then I'm going to use, okay, what happens is that this column names are all off. You see this, right? This is having some bracket and trip miles, etc. In the brackets in SQL is used for creating the functions or initiating the functions. If the names of the columns contains the brackets, then you need to use this what is it called, backtick. This backtick will be on in your keyboard. It will be near to the left of numerical number 1. So wherever the button 1 is there, the key 1 is there, to the left of it there will be tilde or the backtick. So you need to use the backtick. Okay, then if you execute it, it will work, or else you will get an error telling that the column tols is not there. Okay, so just to give you a back feedback, and I am going to further execute this, but here you see that I am actually starting to use alias. Okay, I'm saying, okay, I want to select this value and I want to round it on this value. Okay, I'm going to round is basically to reduce the number of decimal. I don't want these many decimals. I mean, who will want these many decimals, and how will I present it? It doesn't look good. So I want to reduce it to 1 decimal. Okay, and I want to give it a name as tall underscore sum and trip underscore sum. The same I'm doing for trip, and I'm going to execute this again. But here I am saying that, okay, only show me the tall, only show me the column where the tall is more than 58. Okay, and the trip time is more than 10,000. So this is another way of filtering. And I am executing this, and it will execute, and it would have already got changed. And again, here I am going to use the similar kind of role, and here I am going to change the order. So instead of having ascend, this does not look to have any kind of order. So in order to get an order, we can use order by clause here. So I'm going to execute that, and it will come as an order here. Okay, and now we are almost coming to the end. Okay, Now we are going to check the Spark warehouse. I told you that we have to write the table to the Spark catalog. So the Spark catalog basically is inside the folder called as Spark warehouse. Okay, this is the database server. If you list the database server, you will see that there are two tables here: disp origin license and jan underscore B02682. So these are all both the tables that we wrote. This table, disp origin license, and the earlier table that we wrote. Just a minute. Yeah, this table that we wrote. No, not this. Just a minute. Yeah, this table that we wrote. Both are actually folders inside the Spark warehouse. That is one thing that I wanted to show you. Okay, and you see that the even though the table name that we have provided is having a capital J, the folder name is still having small j. So keep this in mind when you are when I made a mistake here, but I still want to show that you need to properly name your tables. Now what we are going to do is let us first of all list this value. Okay, if I come here, now I can actually create the table based on the this particular folder. Okay, I can actually ask Spark to read this folder and create a table. And if I execute this, you will see that there are multiple files here. Okay, and something is wrong here. Just a minute, give me a moment. Okay, so we are not going to read it from this file. Okay, we are not going to read it from this database. We are going to read it from this place. Okay, we actually created Parquet files manually. That Parquet files we are going to read now. Okay, so I actually went to the wrong place. So remove this and use this. So if you list it right now, so you will see all this folder like this. The folder is like this. This folder I am going to read into Spark catalog directly. So I am not even going to read it as a Spark data frame. Understand? I am going to read it as Spark catalog. It will create a new table in the catalog itself. So like this, you can read CSV files also. Like this, you can read text files also. Okay, this is the benefit. So this is what happens if you have been working with AWS, and there is a concept called as glue catalog in AWS. The same thing happens in glue catalog also. What happens is that in glue catalog, you will be given the file location. So the file will be like this in folders. Let me show the file actually. Let me see whether I can open the file. Just give me a moment, because it could be difficult. See, because the challenge here is that sometimes it doesn't load. Yeah, it is loading, and yeah, let us see whether it loads here. Jan underscore Jan. So this is the folder in which all the Parquet files are there. Okay, and we are going to load all the Parquet files into the Spark catalog directly. So it is taking a little more time. Let us give it a little time. Let us see now. Okay, so when it loads, I am going to load this. I am going to use create table. So it will immediately read it. So it will read the entire folder, and it is saying to me that I have read it and the data frame is created. It is also giving me the schema of the whatever data has been read. Okay, now all I need to do is see, previously what I did, I created the data frame, and then I told to save it as table. But now I am not doing anything. I am just directly using this table name, and I'm going to execute this. You will see that, oh, what happened? There is no data. I was about to show you the data, right? Okay, hold on. This particular Parquet file folder was actually created as partitions. Okay, so we partitioned it based on the request date. So all the data here inside is partitioned based on each and every date of January. Now I actually created the table. Spark catalog knew that, okay, there is a data set here. Okay, let me close this. This is not working out. So Spark catalog knows that there is a data in this location. Okay, that location has a table name, this one. So I am giving this, but it is not working. Okay, but now I want to see the partition. So you can you can actually make the show partitions, and you can check the partitions, and we see that there's no partition also. One way to get back the data, actually, the data is still there. One way to read the data is to use recover partitions. So once you use this method, the partition will get recovered. It is as simple as that. And now when you show this, then you will see all the partitions are available. So it will show. And now when you read the tables, now it will read the table. Okay. Now you will read that the request date is so and so, and it will start reading everything. So there will not be any challenge anymore. And you can, if you want, you can actually count it, and you can check it how many data is there based on the I grouped it on request date. So it will give you all the data. So it is showing top 20 rows. So if you want to say, I want to see top 31 rows. So let me execute it again. So you will see all the 31 days. So that is how, let us go back to the presentation. So we saw that we can actually practice on massive data sets on Kaggle, and by using Uber New York dataset. We did that right now. We loaded the dataset and we started transforming it. We did use group by with column select clauses, and we created the table in the Spark catalog. So this activity is very important. We created the table in the Spark catalog. We wrote the data frame to the local environment, local file system. So we did all these things in this video. So we actually did the ETL process. So we extracted the data, we transformed it, and then we loaded it in the different file location. All these activities we did. And then we also worked with the partition data. I showed you how to create the table in the Spark catalog and how to work with the partition data. Here, one of the major point I did not touch is that I did not touch anything about SQL. Okay, SQL I used a lot of commands, SQL commands, but I assumed that you are confident in your SQL skills. However, if you are not confident, do practice SQL extensively, especially on the partitioning aspect of the SQL and the window functions and basic functions, basic date functions, and the consolidation functions like group by clauses. All these things are very important. So you saw that managing data warehouse, the data inside the data warehouse actually depends on how effectively you can partition, not just partition, how effectively you can filter the data. Okay, and for filtering, you still have to understand basic SQL. Let us go back. So where it is. So I use select, right? So I'm using select here, and this particular command is basically select all this column from table Uber full data. This is what it is doing, and I'm still following the SQL format only, but the syntax is little different. Okay, so that is why I'm insisting again. You can do all these things in a very limited environment also. You can do it in the data warehouse also. In data warehouse, the way we check these whether the files are available or not will be little different. So instead of using ls directly, we will use hdfs ls. So there is a different command for that. I'll be going into that in a different video. So stay tuned for that. I will show how to create the data warehouse and then start working on that. So I'll be using, I'll be doing the video in a little time. So yeah, let us go back to the presentation. So we have seen the entire process. So watch the video a couple of times and practice. Okay, practice. Now you have the location to practice. There is nothing stopping you, and you have the data sets also. So whatever data set you want, 1 KB data set or 100 GB data set, whatever you want, it is available in Kaggle. So you can use that, and you can easily load the data set and work on your transformations, and you can use the resources available effectively, and you can learn big data related concepts very easily and practice. Practice is the most important to master the art of big data ETL with Pyspark. So we have come to the end of this video. I hope that you like this content, and do share this content with others who are actually trying to start into data engineering or big data, and subscribe to my channel. I have a series of videos planned. I will be linking the playlist that this particular video is part of. Take a look at the playlist also. you will get a better insight about the entire Python ecosystem. So PySpark is part of the ecosystem, but PySpark itself is having its own ecosystem. So it's a very big library, very big solution set for the various problems that the big data engineers face. So I'll be next going into DBT or data build tool. So for that, stay tuned, guys. And till then, have a great time and do practice. Practice is more important. And if you have any questions, do comment in the comment section. I will be responding as soon as possible. So till the next video, see you guys and have a great time. Practice, practice, practice.